Hello, this is the third fraction computation quiz that we took, and here are all the problems worked out. This video should be used to study the different types of problems, so if you need to fast forward to one of their problems in the quiz, I would suggest you do that. Let's begin at the first problem. So we're going to add mixed numbers that have fractions with different denominators. So there are different denominators. I need to convert them into the same denominator. In this case, they're both prime, so I'm just going to have to simply multiply each by the other's denominator. So this becomes 12 and 25. 25 35ths plus 9 and 28 35ths. 12 plus 9 is 21. 25 plus 28 is 53 over 35. And this is, since the top is larger than the bottom, I can regroup this and make at least get one more whole out of this. Because I can get at least 135. So this be 53, the same thing as 35 plus 18. 45 plus 8, yes. So this becomes 22 and 18 35ths. There's no common factor between 18 and 35, so this is my final answer. In this problem, I'm going to subtract 7 and 5/6 minus 3/9. Different denominators, so they have to be the same denominator before I can convert. I could multiply both of these by the other denominator, but I noticed that 18 is a multiple of 6 and 9. So I'm going to change the bottom to 18 by multiplying the 6 times 3 and the 9 by 2. This becomes 7 and 15 18ths. This minus 6 18ths. Now I can do my subtraction because the denominators are the same. 15 minus 6 is 9 18ths. And I can divide both of these by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. So this is 7 and 1/2. Next problem I have here is 22 and 5/9 minus 6 and 5/6. Same two denominators again, so I am going to use 18 as my common denominator. When I do that, this becomes 22 and 10 18ths. This becomes 6 and 15 18ths. So I have 10 18ths minus 15 18ths. Can I take 15 away from 10? No. So that means I'm going to have to borrow from the 22 and rewrite this fraction. So 22 is the same thing as 21 plus 1. And the 1 I'm going to write as 18 18ths. And I'll add it to here. So now I have 21 10 18ths plus 18 18ths is 28 18ths. It's hard to see, isn't it? Minus 6 and 15 18ths. Now, since the 28 is larger than 15, I can take the 15 away from the 20. So my whole numbers, 21 minus 6 is 15. I'm talking 18ths. So 28 minus 15 is 13. And this is the end because I know, because 13 is a prime number. There's my answer. Now, looks like we have some multiplying. So the first thing we're going to do is we're going to change this to an improper fraction. 3 times 3 is 9, plus 2 is 11. So 11/3 times 3/4. Now I could just multiply straight across. When I do, I have 33 over 12. Can this be reduced? Well, yes, it can, because both of these are divisible by 3. 33 divided by 3 is 11. 12 divided by 3 is 4. And as a mixed number, I can get at least 2 4s out of 11 with 3 left over. So that works by multiplying straight across. However, I can come back here and I notice that I have the same factor in top and bottom. And if I simply cross those out, which I can do because 3 divided by 3 is 1. 11 times 1 is 11. 1 times 4, and I have the same thing here, 11 fourths, which is going to simplify once again to 2 and 3 fourths. Okay, so now we have a mixed number of times a fraction. Let's change it to an improper fraction. 9 times 8 is 72, plus 4 is 76 ninths, times 6 twelfths. Okay, if I multiply straight across here, 76 times 6 is going to be 456. 9 times 12 is 108. Now that's not so friendly. I mean, we could do this. We could divide. And you can see right now that it should be 4 and a little bit more. Excuse me. So, because 4 times 100 is 400, and I should be able, this will be 4 and a little bit more. But this goes to show why canceling beforehand can be more helpful. So I'm going to do that. So let me write this problem again one more time. And I noticed that 76 is even, so I'm going to write this as 2 times 38. And 12 is even, I'm going to write that as 2 times 6. 9 can be written as 3 times 3. And 6 can be written as 2 times 3. So now I have some things I can cancel. I can cancel a 3 here with a 3 here. I can cancel a 2 here with a 2 here. And what I have left is 38 times 2 is, I'll write that 38 times 2. And the bottom I'm left with 3 times 6. Well, 6 is the same thing as 2 times 3. So 6 I'm going to write as 2 times 3. So this 2 times 3 is this 6. But why did I do that? So I can cancel this and this. So now I'm down to 38 on top, and 3 times 3 is 9. Well, now this is a lot more doable. How many 9s are in 38? Well, 9 times 4 is 36, so I get 4. That matches up. And that leaves me with 2 left over, so 4 and 2 ninths. There's my solution. Now in this case, if you looked carefully, there was another way to do this problem that required you to think carefully about the problem itself. While the rules we have been using to multiply fractions work, sometimes if you pay close attention to a problem, there are shortcuts, and this is one. So I'm going to rewrite the problem here. And this we can actually do mentally. So here's 8 and 4 ninths. But 6 twelfths, if I reduce that, that's simply just 1/2. So what is 1/2 of 4 ninths? Well, what's 1/2 of 8? 4. What's 1/2 of 4 ninths? 2 ninths. So I get the same answer that I did here, just by seeing the problem a little more clearly. One more problem here. So now I have 2 mixed numbers I'm multiplying. So let's first change it to an improper fraction. 8 times 5 is 40, plus 5 is 45, so 45 over 8 times 3 times 3 is 9, plus 1 is 10. 10 thirds. Now if I multiply straight across, which I can, I get 450 over 24, which isn't the end of the world, but it is larger than what I like to deal with. So I'm going to come back over here, and is there anything I can cancel? Yeah, look, because that's an even number, and that's an even number. And 3 is actually a factor of 45. So 45 is the same as 3 times 15. And 8 is the same as 2 times 4. 10 is the same as 2 times 5. And 3 comes down. But now I have some things I can cancel out. I can cancel out this 2 and this 2. I can cancel out this 3 and this 3. And on top I have 75. 5 times 5 is 75 over 4. All right, so how many 4s can I get out of 75? 4 goes into 7 once. 1 times 4 is 4. I subtract it. 7 minus 4 is 3. I bring down the 5. How many 4s can I get out of 35? Well, I can get 8. 8 times 4 is 32. And that leaves me with 3. So my final answer then is 18 and 3 fourths. So use this little video to go over particular types of problems, and you will quickly too be in charge of all these various fraction computations. Goodbye for now.